Okay, so in this next lab you're going to look at velocity. Now, I want to write down the equation for velocity. General equation is velocity is equal to a change in position, which we're going to use delta x, divided by a change in time. So, on our setup, we have a cart that's going to start at a particular position. It's going to roll down the cart, and it's going to take a certain amount of time to get down. So we have a distance that we travel. Say, for example, we go from 100 centimeters to 0. 100 centimeters to 0 would give us a change in position of 100 centimeters. Let's just say also that it took about, just using a number off the top of my head, 3.2 seconds to go down. So from start to finish, it took 3.2 seconds to go down. Your change in time would be 3.2. Now, typically, whenever you are doing calculations, you don't want to have centimeters. So we're going to want to convert the centimeters into meters. So this would be 1.00 meters divided by 3.2 seconds. And when we do this calculation, we should get a value that is 1 divided by 3.2, 0.313 meters per second. Okay? Now what this is exactly, it's not obvious at first, but as the cart starts, it's changing its velocity. And its velocity gets greater and greater and greater and greater and greater as it goes all the way down. When we find the average velocity is before it gets to the halfway point, it's going less than 0.313. After the halfway point, it's going to be more than 3.13. So it's only right in the middle of the starting point and the finishing point does this cart actually go around 3.13 meters per second. And that's why we have to mark off our 50 centimeter mark, because that's exactly halfway. And that's what you need to keep in mind when you're doing this lab. All right?